Hello everyone, welcome to what will be pre-lecture 8. This is going to be walking us through how to build Lewis structures. Okay, so just to give you a preview of what you should know to do by the end of class, you should be able to draw Lewis structures for simple molecules given the molecular formula. You should also be able to identify, name, and provide formulae for listed polyatomic ions. We're going to talk about that on the next slide. And in class, we're going to talk about what hypervalency means and be able to identify atoms that are able to be hypervalent. Okay? So this is technically from chapter 1 in our textbook, but it is time we talked a little bit more about nomenclature. And so these are common polyatomic ions, if I can talk correctly, that I will expect you to know throughout the semester. And so we have them grouped here by -1 ions, -2 ions, -3 ions. The reason we basically want you to memorize these is because they're very important. They come up a lot. You're going to need it this semester, next semester for chemistry. They're also in a lot of biology, as well as some other courses that you'll encounter them in. Okay, so just to kind of walk through these first couple have a carbon or multiple carbon atoms in them, so hydrogen carbonate or bicarbonate, it's the same thing. Acetate is another common one. And then we get into our nitrogen polyatomic ions, so nitrate and nitrite. As a general trend, if you have an A for an 8 at the end of a word, that generally means it has more oxygens. And so nitrate has 3 oxygens, nitrite has 2 oxygens bound to a central nitrogen. And then if we put a per in front of the word like this, that means as many oxygens as it can take, basically. So permanganate means it has 4 oxygens. And that's going to be very similar to something like perchlorate that has ClO4 minus. Okay? Cyanide is another one that contains carbon. It's a minus charge. And another super common one, definitely going to be talking about this a lot, is hydroxide, OH minus. Okay? Then we have our chlorine oxyanions, so O4, 3, 2, and 1 that go perchlorate, chlorate, chlorite, and hypochlorite. Those are good ones to know as well. Okay, for our 2 minus ones, carbonate, and then we get into our sulfur-containing ones, sulfate and sulfite. I will tell you, you don't need to know thiosulfate for this class at least. It may come up later, but that is one you don't actually need to know. Then peroxide, chromate, and dichromate. Okay, and those all have a 2 minus charge. And finally, our phosphorus-containing one, phosphate, boron-containing one, borate, arsenic-containing one, arsenate. Okay, so I do expect you to have these memorized by the end of the week. I would expect a quiz question that says, what is the name of this polyatomic ion? And I give you a formula. You have to name it. Okay? All right. Moving on to chapter 4 then. We talked about Lewis structures, or were at least introduced to them last class. And so Lewis structures, just as a reminder, are a way that we can represent covalent chemical bonds based on the number of valence electrons that an atom has, or multiple atoms have. So water is an example we went over in class. Something that we drew but didn't necessarily name last time are bonding domains and non-bonding domains. So if we have a line, if we have a bond between 2 atoms, we call that a bonding domain. We can have a double bond or a triple bond. That would still be considered a single bonding domain. In this case, we only have 2 single bonds, so 2 bonding domains. Then we have what we'd call 2 electron lone pairs. So anytime we have just a pair of electrons, those are non-bonding domains, meaning that they are not currently being used to form bonds, and that means that those electrons belong only to the oxygen, and they're not shared with the hydrogen atoms. Okay? As far as rules for drawing Lewis structures, we can follow a pattern, and this should work for just about every Lewis structure. In class, we're going to talk about some more advanced examples, but if we start simple, first thing we want to do is determine the number of valence electrons that each atom will contribute in the molecule. Okay. Next up, we want to draw a skeleton with any of our non-central atoms connected to a central atom through single bonds. And so a hint for you if you're ever trying to determine what the central atom is that the element that is listed first is almost always going to be that central atom. So I would start there. And then third step, place 8 valence electrons in the shells of all of the atoms through the addition of lone pairs. So if we have a central atom connected to our outer atoms through single bonds, then we add lone pairs to give everything an octet, or if it's hydrogen, maybe just a duet. And if you end up with too many electrons, you'll want to replace some of those lone pairs with double or triple bonds in order to get that number to agree with step 1. Okay. I would recommend you practice these. We're going to start class by doing these together. So PCl3 and CH2O. So go ahead and practice with those on your own, and then we'll go over them to start class. But that is all for today. Hope it was useful. If you have any questions, please do let me know. Otherwise, I will see you in class.